Good morning, evening, good afternoon. Maybe it's midnight where you are. I'm not sure, but hello, my name is Samantha Carey, and today I'm going to be talking to you about the analysis of game fish and panfish species abundance pre and post a Renovate herbicide treatment on Saratoga Lake, New York. Again, my name is Samantha Carey, and I am here from New York today. I am with SUNY Cobblescale as well as SUNY Oneonta, where I am doing my master's degree under Dr. Daniel S. Stitch. I'm sure some of you know him. He is the R guru running the R workshop this week. So obviously my presentation is going to have some modeling in it and some cool fisheries data, and I'm excited to share this with you. So let's get started. All right, so here we are at Saratoga Lake in Saratoga County, New York. I'm going to throw a map up here for those of you who are unfamiliar with New York State. That red shaded area is Saratoga County, and that can be found right above our capital district. So Saratoga Lake is a well-known recreational spot for folks all around the state as well as locally, and the lake offers boating, swimming, fishing, all the good stuff we love about our water bodies. So we're going to travel back in time here a little bit. We're going to talk about this study that occurred in 2007 to 2009, and it was a collaboration between the Saratoga Lake Protection and Improvement District along with the Saratoga Lake Association. These two collaborated, and the result was the Saratoga Lake Invasive Species Long-Term Management Plan. So with that Saratoga Lake Invasive Species Long-Term Management Plan, multiple options for management were outlined for stakeholders. A Renovate aquatic herbicide treatment was used to control Eurasian water milfoil within Saratoga Lake, and there are a few other invasives within the water body that weren't targeted at this time: curlyleaf pondweed and watercress. Saratoga Lake is known to have a pretty robust aquatic plant community, native aquatic plant community, and this complements the robust fish community. There are a ton of different species within this water body. You have basses and pickerel and yellow perch and walleye and all of that good stuff. So this system is really driven by the aquatic plants and the fish community. The objectives of this study were to observe the impact of the Renovate aquatic herbicide treatment on the rooted aquatic macrophytes of Saratoga Lake. I also wanted to examine the changes in fish community structure and abundance within the littoral zones. So the goals of this study were to 1. Conduct a pre-treatment survey to establish baseline fisheries data 1 year prior to application. 2 was to perform post-treatment surveys 6 months and 1 year after application. And 3, to use non-metric multidimensional scaling, a package within R, to examine changes in game fish as well as the panfish abundances over the 3 years of the survey. All right, so here we are, another map of Saratoga Lake. This time we are looking at the Eurasian water milfoil treatment areas within the water body. 292 acres were actually treated on this northeast shore that you can see here. So Saratoga Lake is actually pretty large, has 1,500 hectares, mean depth of 8 meters, max depth of 30 meters. That works out to about 25 feet mean depth and 90 feet max depth. Robust fish community, like I mentioned earlier, a bunch of centrarchids, which are your basses and your sunfish, and then you have your assacids, which are your northern pike and chain pickerel, and then your persids, your walleye, your yellow perch. And that's great to have all of those different types of organisms within a water body. So again, that herbicide treatment was on that northeast shore, and fall surveys occurred in October of 2007, 2008, and 2009. So for this data collection, night electrofishing was performed using a Smith Root electrofishing boat. Alternate game fish and all fish runs were performed. These were all near shore in shallow water, less than 2 meters in depth. This is typical when electrofishing because the field sometimes cannot reach more than 6 meters and you do want to collect all of the fish. Littoral zone temperatures were between 10 and 18 degrees Celsius, and this was following the Persid sampling manual from Forney et al. 1994. So our methods for data analysis were the use of non-metric multidimensional scaling, or NMDS for short, in R. It is a modeling package that's typically used in ecology on complex non-normal data sets. I'm sure all of you know being in anology, biology, ecology, limnology, you have a lot of complex, not normal data sets, and this is a really good way to look at them. So the NMDS method takes a technique of trial and error to find the best arrangement of points in ordination space. So this collapses information from multiple dimensions, such as sites or species, communities, years, into just a few so that they can be visualized and interpreted. So I like to think of it as a big ball of data, like a soccer ball or a kickball, and then you squish it on a piece of paper and it becomes 2D, and you can see all the interactions between the different dimensions. So I just wanted to start off with a few results here before we got into the graphs. Take these results here, apply them to the graphs. You can see a connection, apply them to the statistics that I tell you. But in this survey, overall fish collected decreased over time. So from 2007 to 2008 to 2009, there was less fish every year. There were clear trends in the raw data, and these were backed up by the NMDS models. So the number of bluegill collected decreased with each sampling event. The community changes that occurred are able to be seen in the statistics as well as the graph, abundance changes, and then it turned into a predator-dominated area within the lake. Visual plots of NMDS were created to show both species and site correspondence, and ellipses were added around the plots to show the 95% confidence intervals. These graphs may be pretty, but they do lack statistical data to draw conclusions from. So with that, we had to perform a Bray-Curtis dissimilarity matrix, which is understood by running an analysis of similarities model, or an ANSO model for short, which is used to determine if the dissimilarities between groups is greater than the dissimilarities between species within groups. So we had an R value of 0.58, which suggests that there is dissimilarity between the years. The years are the groups. The significance value of p equals 0.004 indicates that the dissimilarity between years was greater than the dissimilarity within years. So what that's saying is that species composition has changed from 2007 to 2008 to 2009. So this is the same graph that we were just looking at, but I just want to drive home the idea of that dissimilarity between sites and years is greater than the dissimilarity within sites and years. So what that's saying is 2007, 2008, and 2009 are very different in regard to species composition within the years. So they have changed. 2007 was dominated by panfish, and 2009 is dominated by large predators. So we can look at this graph to understand that. So in 2007, BG and PS are within that 95% confidence interval ellipses, and they are plotting close to that site. So species that plot closest to sites are usually in high abundance at that location. Species that plot far away don't normally occupy. We'll get there in 1 minute. On the top of that graph right there, you have brown bullhead, which we would expect in flocculent areas, mucky bottom areas. We caught a few there. You go to 2008, you're looking at the graph. Okay, largemouth and yellow perch. Well, this is the predator-prey dynamic at this point because 2008, we started to lose some of the aquatic macrophytes. Bluegill and pumpkin seeds not occupying as much. If you look at the raw data, they're really not there either. It's nice when you can see trends in the raw data. And so it's a largemouth bass and yellow perch fishery at that point. You have some chain pickerel coming in, as you can see at the top right there, kind of out in nowhere land. And then you go to 2009 and you're looking, and it's WE and SMB, walleye and smallmouth bass. Those are the predators that are occupying those sites in 2009. You have northern pike all the way out in right field there. We caught 2 of those in that survey, but there are no bluegill or pumpkin seed. And you can say that vice versa. There were no smallmouth bass and no walleye in 2007. Where were they at that point? And where are the bluegill and pumpkin seed now? And that's kind of the questions that we were looking at. So we're going to go into a little bit more of the results here, more of the meat and the potatoes. But we're going to talk about 2007 real quick, that pre-treatment survey. As we just saw in those graphs, it was bluegill country, bluegill city, whatever you want to call it, but you had those increased amount of aquatic macrophytes at this time. It was a refuge place for prey species from large predators. It was a place for them to eat. It was a place for them to spawn. It was a place for them to stay protected. Again, that refuge habitat, those were important areas for them, and they were able to hide and escape predation. And then you go 6 months out in 2008, and this is a post-treatment survey, and that whole dynamic has changed really to largemouth bass and yellow perch, which are occupying these same spaces now. Panfish populations are decreasing, you're not seeing them as much, and that kind of suggests that there's an increase in sunfish vulnerability to predation, most likely due to the treatment and the lack of cover. All right, so we're going to go 1 year out to the 2009 1-year post-treatment survey, and this is the first time we see northern pike show up in one of our surveys. None in 2007, none in 2008, and this could be related to the changes in the forage space, so the decreased amount of prey species can prompt pike, or pickerel, I guess, to move into the shallows to feed, and at this point, there are no bluegill or pumpkin seed detectable within the littoral zone. So from these night electrofishing surveys 1 year out, not a single bluegill or pumpkin seed were caught. These are those important prey items for these predatory species. So that low CPUE could be associated with the decreased amount of cover, and that can increase the vulnerability of predation and lack of spawning habitat and lack of a food source for these panfish, and they just decrease within the area. Alright, so I know we've seen this graph a few times, but I just wanted to drive home the point of these graphs and how they are a really good visual tool to help visualize data, and then pairing it along with some statistics can really make a great case for some of these habitats, and this could be used for really anything. NMDS is great. So again, 2007, we have that bluegill, pumpkin seed dominated area, panfish dominated, dense stands of aquatic macrophytes. You move to 2008, they start dying. You have largemouth bass and yellow perch. That's that predator-prey dynamic there. Then you move to 2009, a lot of plants have been eradicated at this point. Walleye, smallmouth bass, northern pike, hanging out here. Straight predators, no panfish collected, and we can see that in the next graph that I'm going to show you, which is the raw data from our runs. So here we are, a quick look at the raw data. It just kind of ties things in, and you can see that in the NMDS plot, as well as with your statistics. So 2007, bluegill, super abundant, 73 at site 1. You have a good amount of largemouth bass. Then we go to 2008, and you can see that bluegill, the 6-month post-survey, are really decreasing at this point. Largemouth bass really maintaining the same, or actually having a little bit more now. Maybe they have a little bit more to chase around and to eat, and maybe they're occupying this area. We also see yellow perch in this area. Come to 1 year out, we have the least amount of fish caught at this time, 109 fish, compared to 273 and 253 the years prior. No panfish at this location. You have some black crappie, but in limited numbers. You do not have those bluegill, you do not have those pumpkin seed, you really don't have that forage space for the large predators. So just a quick wrap up on those results. 635 fish collected throughout this survey. The Ansholm statistic R value of 0.58 suggests that there's dissimilarity between sites and years. That p-value of 0.004 indicates that it's a significant difference, and that NMDS stress level is 0.05, which is an excellent representation of those reduced dimensions. So again, taking those multiple dimensions, squishing them down from that ball of data into a 2D format, and able to analyze and statistically understand the data you're working with. So just to wrap up some conclusions here, sites with high abundances of specific species may have favorable characteristics desired by those species. So talking about those bluegill and pumpkin seed, they were really abundant in the beginning there with that excessive aquatic macrophyte growth from the invasive species. They liked that area. But with the decreased aquatic macrophytes, it's caused species to seek forage in the reduced littoral zone. And big predators come in and prey upon those panfish, and either those panfish have been getting outcompeted or they've migrated to new, more suitable habitat. But the low CPUE can definitely be associated with a decreased amount of cover, makes them more vulnerable. And this kind of just drives home the message of how one thing can always impact another. Aquatic plant management can impact fisheries management. It can impact water quality management. It can impact everything, and that's something we all need to keep in mind. So this was an awesome data set to work with. Got to see some really cool fisheries data, some really cool modeling, some really good statistics, and I thoroughly enjoyed working with it. And there are some people that I need to acknowledge because I actually didn't go out and collect this data. I was in 8th grade at the time. So I do want to thank my boss, who I'm sure I'm making feel very old right now, Mark Cornwell from SUNY Cobleskill, along with the SUNY Cobleskill fishery students who assisted on these night electrofishing contracts, the New York State DEC, my advisor, Dr. Daniel Stitch, Saratoga Lake Association, and the Saratoga Lake Protection and Improvement District. So I hope you enjoyed listening to me today or tonight or wherever you are in the world, and I look forward to hearing any questions, and I hope that you have a great day. Thank you.